After learning how to evaluate series, we are now going to look at the concept of limits of a sequence. What does this mean? Let us consider an example. Suppose we have the following sequence. Now remember that a sequence is just a list of numbers in a particular order. So let's say we have un, which is 1 plus 1 over 10 to the power of n, and this sequence holds for n equals to 1, 2, 3, and so on and so forth. Now, before I can begin this discussion, and for you to have a complete understanding of this chapter, I need to ensure that everybody is very clear on what this un means. Okay, this n means that this is the nth term of the sequence, which means that my first term will be u1. And if I were to substitute in, u1 is going to be 1 plus, now since I'm taking u1, my n over here must take on a value of 1. So 1 over 10 to the power of 1. So this is going to be 1.1. Okay? Now, u2 is going to be 1 plus 1 over 10 squared. So this is going to be 1.01. u3 is going to be 1 plus 1 over 10 cubed. So this is going to be 1.001. Do you see a pattern emerging? Now, what do you think u4 is going to be? I'm sure most of you can tell immediately that it will be 1.0001. As my n gets larger and larger, what do I notice about these numbers? Can you see that my numbers are all tending to a particular value? As I have more and more zeros here, in fact, as n goes to infinity, my number of zeros will go to infinity, right? So this means that un goes to 1 with an infinite number of zeros before another one. In fact, it's going to a value of 1. Okay? So this concept here of the value as n goes to infinity, un goes to 1, in this case, we say that the limit, okay, to put it in a proper mathematical way, we say that the limit of the sequence is 1. So this value that my number is converging to, this is called the limit. Okay, and note that this is the value that it converges to as n goes to infinity. Now, mathematicians can be quite lazy people, right? I said before. So, this sentence is quite tedious to write. So to write this in short form, what we sometimes write is also as n. Instead of writing goes to, we use an arrow. Okay, so it goes to infinity. un goes to 1. So this is the mathematical way of writing it. So for the rest of this lecture, if you were to see this, I hope all of you understand that this means that as n goes to infinity, the value of each of my terms is going to 1. Okay, and in this case, we say that the limit of the sequence is 1. Now with this, please turn back to your lecture notes, section 4. What I've done is I've actually covered this part, 4.1, okay, up until this point, except for one small thing to bring out. Now, this is what I went through just now, right? Okay, the fact that un goes to 1. So, the other way we write in mathematical notation is this way. Okay, let me write it out with you. So this lim is not a surname. What it means is the limit. Okay, so in red, this means the limit. Limit of what? Limit as n goes to infinity. Okay, but instead of writing n goes to infinity, once again we just write n goes to infinity. Okay, so this means the limit as n goes to infinity of un. Okay, so without the word of, we just write un. And this limit is equal to 1. Okay, so I hope all of you can understand this notation. And that's it for section 4.1. So in general, if un is the nth term of a sequence, and the limit un as n tends to infinity exists, please highlight this, the sequence is said to converge. And this value is called the limiting value or the limit of the sequence. Now, why do I say if over here? This is because there are actually times when the limit of a sequence does not exist. Okay, so this existence over here need not always be true. There are times when, sorry about the color. Okay, there are times when the limit does not exist. Alright, so maybe I will give you an example on one case in which the limit does not exist. Let's consider this sequence. Consider un equals to negative 1 to the power of n for n equals to 0, 1, 2, 3, so on and so forth. Now, what is u1 going to be? Observe that I have a habit. When I'm not very sure what the sequence looks like, I start with small numbers and I try and observe. Sorry, so I start from u0, not u1. Okay, so u0 is going to be negative 1 to the power 0, which is 1. u1 is negative 1 to the power of 1, which is negative 1. u2, it will be negative 1 squared. So this is going to be 1. u3 is going to be negative 1 cubed, which is negative 1. So what do I observe about this sequence? This sequence is in fact this 1, minus 1, 1, minus 1, 1, minus 1. So on and so forth, all the way to infinity. Now, can I deduce what the limit of the sequence is? Well, it looks like it should be either 1 or minus 1, right? But when n goes to infinity, how do I know whether infinity is an odd number or even number? I cannot tell. Okay, so in this case, this sequence is not convergent. And because we see that it oscillates between two values, 1 and minus 1, hence, we say that this is an oscillating sequence. Okay, please take this down because this example is not in your notes. And you are expected to know the term oscillating sequence. Alright? Okay, now before we can go on to evaluate limits of sequences, here are some important things which are useful. Okay, so please put a star at this table. As n goes to infinity, 1 over n goes to 0. Now why is this? I'll work through each of these with you very quickly. So now n goes to infinity, this is a very hard thing to visualize. Okay, so what I normally advise students to do is we substitute in maybe a very large number of n. For example, n equals to 999. Okay, so then 1 over 999, it should be quite close to 0, right? So that's why as n goes to infinity, 1 over n should go to 0. So similarly, this one should be no problem. It follows the same logic. 1 divided by a very big number, it should go to 0 as my number gets bigger and bigger. Now what about this? R to the power of n, if r is more than 1. So one example of a suitable value of r will be r equals to 2. So taking r equals to 2, okay, I see that 2 to the power of 999, this is going to be very big. Okay, so therefore, as n tends to infinity, r to the power of n should also tend to infinity. So this is an example of a sequence which does not converge. In fact, it diverges. Okay. Now, finally, if r is between 0 and 1, what does this mean? R is a proper fraction or a decimal that is less than 1. Okay, So values like 0.5. Now let's key in one example, 0.5 to the power of 999. Can you see that this is also approximately 0? So this is why r to the power of n will tend towards 0 if r is between 0 and 1. Okay, so now I have laid the foundation of what a limit of a sequence is. In the next video, we will look at some ways or common methods to evaluate the limit of a sequence.